Hey, kiddos. So here we are. This was the last question and the most challenging one that I gave you on Tuesday because it doesn't really ask you to solve anything. It asks you to justify a statement by a student. We want to justify whether or not they're correct or incorrect and then be able to prove why they are or not and be able to think our way around that. So I wanted to walk you through this so that we can look at what the student is saying and understand what the student is saying and hopefully come up with a solution that makes sense. So the question says a student had stated if you double all of the dimensions of a triangular prism, you will double its surface area. Is the student correct, yes or no? And then it goes on to ask you to justify your answer. Now, you might be tempted to just say yes. If they double the dimensions, then that just makes sense. But it's math, and they're asking us this question for a reason. So let's dig into it a little bit deeper and see what does this really mean. So if we're being asked to double a dimension, that means we're talking about all of these things here. So what I've done is I've made a triangular base prism right here, and I have put the dimensions of the triangle base prism in here. So the dimensions are, the 4 units of this side, the 3 units of this side, the 5 units of this side, and it's 10 units long. So it's asking us if we double all of those numbers, if it's going to double the surface area of this prism. So let's start off with just looking at a couple of these faces and calculating them as they are. So if we look at this triangle face on the front here, so here's our triangle face, and we wanted to calculate the surface area of that face as it stands. We know the surface area of this face is, base times height divided by 2. And with the values that we have, that would give us 3 times 4 is 12. And then divided by 2 would be 6 units squared. So as it stands, the triangle bases or the triangle faces of this prism have a surface area of 6 units squared each. That means this one has an area of 6 units squared, and this one over here also has an area of 6 units squared. If I were to double those dimensions, the question is stating that we should have double the squared units on the bottom. Like we should have double the squared units as the surface area. So if I were to turn this 4 into an 8 units, and I was going to turn this 3 into a 6 unit, according to this student, we should have double the units in the answer. So they would say that the area of that triangle is going to be 12 units. Let's test it out and see if that is true. So again, base times height divided by 2, and that's going to give us 8 times 6 is 48, and divided by 2 is 24 units squared. Interesting. So what we have just proven here is that when we doubled those dimensions of that triangular face, we did not double the surface area of that triangle. It was quite a bit more. Let's take a look at the surface area of one of the rectangular faces just to see if our math still works out. So if I was going to look at the rectangular face right here. So here's the rectangular face I'm going to work with. The area as it stands for that particular face is length times width. It's going to be 5 times 10. That's going to give us a surface area for that face is going to give us 50 units squared. So again, according to this student, if I doubled these, if I made this not 10 but 20, and I made this not 5 but 10, I've doubled my dimensions, so they're saying that we should be able to double the answer, which means I should have a surface area of 100. So let's see what happens when I do the math. Length times width, still a rectangle. I'm going to go 10 times 20 units, and the answer is 200 units squared. So again, we have just proven that this student has a misconception somewhere. It does not double the surface area. She is not correct. And the question is why? I've got a couple of visuals here that I think might help to uncover why. So starting off with that triangular base. So this is the triangle that we were working with. This is, it's actually the magic triangle. You are going to be introduced to this triangle over and over and over again in your math career. And the magic triangle has got, you can see dimensions of this is 3, and this is 4, and the other side is 5, but we don't need to know that right now. So you can see in this picture, what we have done is actually physically created a triangle that has double the dimensions. We have doubled this 4, and we've made 8, and we have doubled this measurement of 3, and we have got a total of 6. Now, when we look at the triangle in terms of the area that's being covered here, you will notice if I double the area of a triangle, well, we already know this from our exploration. Doubling the area of a triangle, it's going to give us this rectangle. And look what happens. We actually have that many. We've got that many triangles because there are 2 axes. There's one axis here and one axis here that we're measuring on. We doubled on 2 axes. It wasn't that we doubled it. We doubled the doubling. So we have 2 axes, and what ended up happening was 2 to the power of 2 is the same as saying 2 times 2 is equal to 4. We multiplied the area of this triangle by 4. So that's what happened there. And you can see this again looking at the rectangular side. So this rectangular side here is set up, you know, this right here originally was an area of 10. And we had an area of, or not an area, a length of 10 and a length of 5. And we have doubled it and physically drawn the rectangle that it turns into. So here's my 10, and this is now 20. And you can see again, it is not simply a doubling. We have more than a doubling. We had 2 axes that we doubled. So it wasn't that we doubled it once, we doubled it and doubled it again. So you can see again, we've got this would be doubling, and then we doubled it again. So hopefully this at least gives you a visual of why it doesn't work. I would not expect you guys to go this deep into it. We used a software called AutoCAD to do that. But even if you did this, the math over here, and you just went through it and went, okay, well, if I double it, it doesn't end up working, that right there would be enough to justify to me that you understand that that student is incorrect.